Hey guys, this is Ankit and welcome to the Terraform GCP task series. We are doing a list of basic tasks to get ourselves familiar with Terraform for GCP. We are doing a quest for managing cloud infrastructure with Terraform, available at cloudscalesboost.google/paths. You can always get more details by going to the repository, the cloud terminal 01/learn-devops. For today's task, we'll be spending around 11 to 14 minutes. So let's begin. These are the high-level objectives for our task. We will first understand the code. We will run Terraform, install Cloud SQL Proxy, and finally test the connection to the database created. Let's start understanding the code. We will first go through the main.tf file. Over here, this block of code specifies the Google Cloud Platform provider for Terraform with a version constraint. This provider allows Terraform to interact with GCP resources like compute instances, storage buckets, and networking components. Next, we have Google Beta provider that allows Terraform to interact with GCP Beta resources that are not yet available in production version of Google provider. After that, this block of code specifies a random provider with a version constraint of 2.2. The random provider allows Terraform to generate random values during resource creation, which is useful for testing and creating unique resource names. Here, this block of code defines a Terraform resource of type random ID with the name as name. This resource is used to generate a random identifier value that can be used in other resources or modules. Now this resource block declares a resource of type Google SQL database instance with the name as master. The name is populated using example-SQL random ID, which we declared over here. The values for project, region, database version, and master instance name are populated using the values provided in these variables. These are of course declared in variables.tf file. Now the settings block includes various configurations for the database instance such as tier, activation policy, disk auto resize, etc. Next, you will find a lot of dynamic blocks inside the settings block. These are used to handle configurations that can have multiple instances. For example, maintenance window can have multiple instances of different configurations, so it is specified as a dynamic block. Let's go over here to check maintenance window. Over here it is set to default, but you can change it as per your requirement. For example, this commented part of code shows the typical values that one might want to set for their database instance maintenance window. This timeout block specifies the maximum amount of time allowed for creating and deleting the instance. Next, over here we have a Terraform resource block that creates a Google Cloud SQL database. The count argument is used to conditionally create this resource. If the value of var.master instance name is empty, then count is set to 1, which means that the resource is created. Otherwise, if var.master instance name is not empty, count is set to 0, which means that a resource will not be created. The name argument specifies the name of the database to be created. The project argument specifies the Google Cloud project in which we have to create the database. The instance argument specifies the name of the Google Cloud SQL instance on which we have to create the database. Next, this particular Terraform code declares a resource block of type random ID, which is used to generate a random identifier. This random identifier is then used to create a random password for the user. Next, this is a Terraform configuration code that creates a SQL user in Google Cloud SQL instance. This line uses a conditional operator to set the count of resource to 1 if the master instance name variable is set to empty or 0 if it is not. This sets the name of the SQL user to the value of variable var.username. This sets the name of the Google Cloud SQL instance where the user will be created. This sets the host where the SQL user can connect from. At the end, this sets the password for the SQL user. If the user password variable is not set, then a random password is generated using the random ID resource. Otherwise, the user password variable value is used. This is our outputs.tf file where we are outputting a bunch of values. And this is our variables.tf file where we have declared all our variables. Next, let's begin with the rest of our subtasks. We will download the necessary files. So I'm going to copy these commands and run them over here. Let's unzip the file that was downloaded. Next, we will start running the Terraform commands. First, we will run Terraform init. I have removed this zip file as we no longer need it. Let's run the Terraform plan command now. And finally, Terraform apply using tfplan. Let's wait for the resources to get created. Till the time our Terraform apply command completes, let's go over our next steps. We will be installing Cloud SQL Proxy on the Cloud Shell. What this basically does is that it provides a secure access to your Cloud SQL second generation instances without having to allow list IP addresses or configure SSL. The Cloud SQL Proxy works by having a local client called Proxy running on your local environment. Your application communicates with the proxy with the standard protocol used by your database. The proxy uses a secure tunnel to communicate with its companion process running on the server. The Terraform apply command is completed now. Let's move on to our next subtask. We will install the Cloud SQL Proxy. So I'll copy this command and give it the execute permission. Now let's test the connection to the database. We will store the required values in the environment variables. Let's get the value for project ID first. Now let's get values for MySQL DB name and MySQL connection name. Now let's run the Cloud SQL Proxy by using this command. So this is completed. I'll open a new tab over here. Navigate to the required directory. Let's get the value for generated password. And finally, test the MySQL connection. The password is this. and I'm connected to the database. And I can show all databases by using show databases command. We can actually go to the Cloud SQL instance by using the console as well. This is our Cloud SQL instance, example MySQL. We created one user with username as default that can connect from any host. So these values we specified over here. This is the username and this is the user host. Also, we created default database name, the value that we specified over here. So this completes all of our subtasks for today. Hope you learned something from the video. If you have any suggestions, disagreements, let me know in the comments. So that's all for today. See you in the next video.